Hi everyone, so this is the second video that I'm going to make related to the final exam. This is all about some practice problems that might help you get ready for the final. So some of these problems will look familiar because they're very similar to what you've seen on exit tickets. They're very similar to what you've seen on previous tests when it came to the force test or the energy test, but it might be useful to work through some problems. So if you need some examples as you try to get ready for the final, here they are. So first, let's start off with some important notes, something I said in my last video. All my classes have both seniors and juniors. So my finals are going to be next week, June 5th to June 8th. My final exam will be partially open notes. Again, that means that you can have your notes from class, the ones that I've given you, the handouts, the practice problems. You can also have handwritten notes, something that you want to bring in, that's fine. What you are not allowed to have are electronic devices. So you cannot just open up your phone or open up Google Classroom to kind of get any kind of help or anything from online. My final exam is on the second half of the year, so quarter 3 and quarter 4, which is force and energy. And then one last thing is I'm going to try to move the room around, move some tables, and maybe do some assigned seats to prevent cheating. All right, so let's go over one of the basic things that we started off with. Just like force is mass times acceleration. So here we have a 20 kilogram box, and it's pushed and accelerates at 1.5 meters per second squared. What force was applied to the box? Now, right now, one thing you could try to do is try to work out this problem on your own. So maybe pause the video, try to see if you can figure out what would you do and what is the force applied to the box. All right, whether or not you paused, let's go over the answer. So here's what you're given. You're given a mass of 20, you're given an acceleration of 1.5, and the unknown is force. All right, so the equation that relates all these things, F, M, and A, is F equals ma. So this is the equation that you want to use. And then when you substitute in your numbers, you have 20 for the mass and 1.5 for the acceleration. And we just multiply these two. And so force is going to be 30 newtons. And that's how much force was applied to the box. All right, let's go over another example. But in this case, we're not given the acceleration. So if you're ever not given the mass, if you're ever not given the acceleration, then you're going to want to do some division. All right, that's true for both of these. So anytime if I ask you for the mass or if I ask you for the acceleration, you're going to want to do some division. So let's look at an example of that. A 20 kilogram box is pushed with a force of 25 newtons. What is the acceleration of the box? Again, pause the video if you'd like and try to work this one out. Okay, so here's what you're given. Force of 25 newtons, mass of 20 kilograms. And what's the unknown? The unknown is acceleration. So again, we're going to use that same equation as before, F equals ma. And if we plug in our numbers here, we have 25 for the force. We have 20 for the mass. And so what you want to do here is you want to divide both sides by 20. So if you divide this side by 20, the 20s cancel out. If you divide this side of the equal sign by 20, 25 divided by 20 is 1.25. And that's the acceleration of the box. All right, net force. So Dr. Lungner and the science teachers compete in a game of tug of war with the math teachers. The science teachers pull to the left with a force of 900 newtons, while the math teachers pull with a force of 880 newtons to the right. What is the net force? So one thing that might be helpful is maybe drawing a free body diagram. And if you guys want to do that, you can. I'm not sure if I'll be able to. I'll give it a shot. So we have, we have some kind of rope. And I know that I have 900 going this way. So I'll try to draw an arrow. This isn't the best work here. And then I know I have 880 going that way. So maybe if I could write some of those numbers, I would. But I'm not sure if my handwriting is going to be great. So 8. It's really you have to remember how to write an 8 when you're using it on a computer. Okay. This is taking way longer than it would if I was using pen and paper. But it's pretty important to maybe draw a diagram to kind of help you think about left and right and directions, because force have directions, and that's actually going to come up here when you try to answer this problem. All right, So anyways, so let's look at what our answer might be. So we were given 900 newtons to the left, so we're going to treat that as a negative, and then we have 880 as a positive. And the net force is the unknown. So we're going to use net force is the forces added up together. So in this case, we only have two forces being added. In reality, you could have 3 forces, 4 forces. You could have so many forces, but if you add them all up, they should be the net force. All right, so the net force is negative 900 plus 880. And so that results in a negative 20 newtons. So the net force would be negative 20. And again, the negative just means that we're heading in the left direction. That's where the net force is heading. That means that the science teacher won. Anyways, what is the force of gravity and the normal force of an 80 kilogram person? Remember that the acceleration of gravity is negative 9.8 meters per second squared. All right, so what are we given here? Not given a lot, just a few things: mass and acceleration. And we want to know gravity and we want to know normal force. So a couple of equations that we can use here. Oh, I think I skipped over that one. Okay, 2 equations that we can use here. Gravity, force of gravity is mass times the acceleration of gravity. And then normal force. Well, normal force is just the negative of the force of gravity. It's equal and opposite to the force of gravity. So first we have to figure out force of gravity, and then we can easily figure out normal force. So you can see here we did force of gravity is 80 times negative 9.8, and that gives us a negative 784 newtons. Again, it's negative because it's going down. And then the normal force is equal and opposite. So the normal force is that same number, but just positive because it's resisting gravity. All right, maybe we'll do one more here related to forces. So Chris is pushing a 90 kilogram sled on the football field. The coefficient of friction between the sled and the field is 0.5. What is the force of friction? So this one's tricky because there's multiple steps that you have to do. So let's write out all the things that we know. So we're only given that we have mass and we have a coefficient of friction, and our unknown is the force of friction. So there's a few equations that we can use. And so let me just show you some of these equations. So force of friction is normal force times the coefficient of friction. Okay, well, we don't have normal force. How can we figure out normal force? Well, I know normal force is the negative of the force of gravity. All right, but I don't have the force of gravity. Okay, force of gravity is mass times the acceleration of gravity. Okay, I can figure that out. If I can figure this out, then I can figure out the normal force. If I can figure out the normal force, then I can do the force of friction. All right, so one thing at a time here. Force of gravity over here, we'll do the mass times acceleration of gravity, and we find the force of gravity on this sled. All right, now the normal force is equal and opposite, so it's that same number but positive, and now I can put this number into my equation for the force of friction. Force of friction is normal force times the coefficient, and that's what you see down here. So the force of friction is 882 times 0.5, and so that results in a force of friction of 441 newtons. That's a lot of friction. That means it's going to take a lot of force to push this thing. But, Chris is a big, strong guy, and, he pushes things around on the football field pretty often, so I think he can handle it. All right, so I'll pause here. I might do a few practice problems related to energy, but hopefully this was useful in case you needed to see some examples.